Please read question 1 from 8 pages old. I want to solve those 8 pages. Then we read the one that has 3 pages and solve as well. Read question 1. Read question 1. Why are you keeping quiet? I know you are not hungry. You cannot be hungry. This is not 4. This is 2 or thereabouts. Read question 1. 3. Or the one I'm. Oh yeah, read. Question 1, please. The one that has 8 pages. Let's be fast now. We can't be wasting time and be saying we want to go home. Question 1. Can you name that girl? Madam, what's doing you? You, the one behind that guy on red. You in her hair. Eh? Nothing. Hope you are with us. You wanna be with us. Oh yeah, read. Let's be fast. I know nobody can faint in my class. If faint, you will not believe it. As you are up, you will realize yourself. Read.
Is that from 4?
No, just read number 1. We did not do no. Okay. A semiconductor, has a resistivity
of 0.5 ohm.
Okay.
And a charge carrier mobility.
Yes, and a charge
Carrier mobility.
Please, if you miss Saturday class, I beg you, go to the YouTube channel, check DC circuit. Behind there, it's not something you are supposed to miss. Check there. What we did there is plenty. So you get the foundation of everything we are solving here. What we did there is plenty. From the first, introduction aspect, step by step. So you need to see how we got the formulas, the principles behind each one. It will help you. Don't think as you're just solving, those things don't help students. How to know how to go about question is knowing the root cause, the principles behind it. No matter how they say the question, it will not be guesswork. Oh yeah? And a charge carrier mobility,
Of 0.02.
Of 0.02
meters What is the drift velocity of the charge carrier?
What is the drift
velocity of the charge carrier? When the voltage then charge carrier.
Is it number 1 you're reading?
It started from number 4.
Is it which one are you reading?
That 8 pages.
Is it number 4, number 1 you're reading?
It started from there.
Hey! Jesus Christ! Or number 4 behind there. We've solved it now. The one that has 8 pages, you don't start from number 1 now.
It's number 1. It starts from.
Please, let me see that. Because you see what we've solved before that we will not resolve. Oh yeah, now number 5 solve. Because it's living everybody know number 4, number 1 and we're supposed to start from number 5 now. Well, let's Google solve it. So, what is the drift velocity of the charge carrier? Well,
Voltage is 10 volts.
when voltage is 10.
Voltage of 10 volts, sorry. Voltage of 10 volts. Of 10, not
It's the same thing. Is that all? Thank you.
It's applied across a 1 meter length.
are here for learning, not entertainment. It's entertainment that will make others to be reading questions. You are just pressing your phone, waiting for the question to be read. Please, be participating. Solution. I've told you before, there are some questions you don't know. Once you write the solution, answer will come. It's read. Oh yeah, so they gave us resistivity. Please have it in mind that whether resistivity is there or conductivity, it should not move you. The main thing is knowing what they're asking you to solve. If you check, every material has resistivity. If you are a metal, it means your resistivity will be low because you have the ability to conduct electricity, while your conductivity will be high. We said that resistivity is actually talking about the resistance to the flow of current due to the type or kind of material. So if the material is metal or a non-metal, a conductor or non-conductor, then you talk about resistivity or conductivity. So know that. So it doesn't mean that you must include it in everything you are solving. So like this drift velocity we are solving now, we don't have to include it because the question gave us mobility and voltage. So we use what we have to solve. So we simply say the mobility mu is equal to 0.02. Then he gave me voltage. Give me voltage of 10 volts. Please, those of you there, you are disturbing my class. Your voice should not be that loud. That you are doing your teaching or whatever, you are that loud. Reduce your volume. So I have this. Now, please, do you remember that we have a formula for drift velocity? When we checked our last class, we got a formula that gave us mu E. This formula, we derived it step by step in our last class. Check YouTube, DC circuits. You will see how we derive this formula step by step. The reason behind it. So when I say E itself from V equals to ER, from V equals to ER, we now say that since we are talking about Y, it should be EL. So make V, E subject of the formula here, you will now get that. So you say remember V equals to here. So E will now be equals to V over L. So E will be equals to voltage given is 10. Then the length is 1 meter, 1. So E will be equals to 10. So this is now going to mean that drift velocity is simply 0.02 times 10. Drift velocity, or punch for me. 0.2. And this is in meter per second. If you say you have textbook, that you like reading your textbook and you're a tutorial student, and if you miss class, you say you read your physics textbook for it. What you are doing is what we call deceiving yourself. Because that textbook, I've gone through it like countless times, over and over. During our schooling days, it's still the same, just that each year they change the back cover. So if you check, you see that even these things like length over area for resistivity and all those things, if you look there, you see that they are just giving you definitions. Things that you just go and master the theory. Then you now come and see when they ask a question, they are not using the formula. You don't know how it came about. So that is the importance of, if you are not in tutorial, you go and check the video to see how everything come about. Because if you say you will read textbook and prepare, some of them will just go and be cramming all those notes there. I don't say for these questions to look as if it's strange. So please, this is how to go about this one. So that's the answer. The drift velocity there is 0.2 meter per second. Read number 5. Read number 5 question.
A conductor has a current of 5 amperes.
Has a current of
5 amperes. And a cross-sectional area 2 times 10. 2 times 10 raised to the power minus 6.
6.
Yes. Meter cube.
Is it cube?
Yes, it's cube. What is the drift velocity of the...
Wait. cross-sectional of area of 2 times 10 raised to the power minus 6. Is that in meter cube?
29.
Hey, let me see your post. You are stressing her. She's the only one reading, so it's not her fault. Thank you. That thing is meter square, not meter cube. Area is not going to have cube. If you missed Saturday class, I tell you, you ought to go and check that video. It's not because you are watching it on my channel, but it's because I know you missed a lot. Because I can't come and open it. I can't come and start telling you what charge carrier density is. When N is this one, when N is that one. But inside the video, you see it here. Yes. Okay, thank you. Well, so, are you solving? Thank you. A conductor has a current of 5 ampere and a cross-sectional area of 2 times 10 raised to the power minus 6 meter squared. Full stop. If the charge carrier density is 1 times 10 raised to the power 29 per meter cube, that thing is per meter cube. What is the drift velocity of the charge? Do you remember all the formulas I gave you for drift velocity? Yes. You don't remember? I have been reminding me. First one I gave you first that V is equals to, instead of S over T, that is now L over T. I gave you this. I also gave you that V is equals to, what is it called? If you come to this QNE, that is instead of NE, you call it NE. Instead of Q, you call it NE. Then you say area and what? Length. Now, if you remember, we said that make length subject form like here. You now have that length will now be equals to VT. See that? So replace this. You now have VT AEN is equals to charge. We said that this thing now, this thing is charge on a wire. Normally, charge is equals to NE in quantization. But when it has to do with charge in a wire, hello, are you tutorial students? What about, madam? Tutorial students? Okay. Okay? Are you a tutorial students? Are you a tutorial students? Behind. Both of you should come, yes. Carry your properties and come. Madam at the back, carry your properties and come. Church charisma, the Catholic. The more you are entering here, the more people will enter. So that will be of the number. Oh yeah. So I said quantization of charge is equals to NE. But when it has to do with wire, we said that it is equals to NE, area of the wire and length of the wire. So replace this length here with this thing. Now you remember that current itself is equals to Q over T. We said that current is simply charge flowing at a given time. I know you see sometimes in textbook they tell you charge on a cross-sectional area per second. Current is simply charge at any given time. So this is it. Replace this now. I equals to, for this, we now have NEAVT all over T. If you replace this, this will cancel this. So that we now have I equals to NEAV. Anywhere you see something like this, velocity in electricity, that is when it has to do with source connected, be it battery, DC, direct current circuit, it means that there is a source. Anywhere you see the velocity there is drift velocity. We don't have anything like ordinary velocity, it's drift velocity. So make this thing subject of the formula. If you make this subject of the formula, you have that drift velocity is simply equals to I over NEA. This is when you are relating drift velocity to current. This is the formula you use. Then if you are relating it to electric field, and I gave you the velocity we know in electric field, that it is called mu. That's what's it called? The charge and the rest. Okay, let's do it. If we know that V is equals to, I'm recapping this, but please take your time and go and watch the video. If we know that F is equals to QE, and that MA is equals to QE, then we normally say that A here will be equals to QE over M, Chevy. We've noted it. When I come and say that, if that be the case, that we have that V itself from this formula, which is V equals to U plus AT, that this at initial will be 0, so V is equals to AT. Replace the A here with everything here, so you have Q over M E, then times this T, everything here for A. We are now saying that the minute you carry this E outside and say, this is V now, and say that V is now equals to Q over M times T, then bring the E outside. This thing and this thing, they are the same thing. We now say that everything that you have right here, this thing now, charge over mass times time, is known as electron mobility. This. So drift velocity when you are relating to electric field is going to be electron mobility times E. This is where you now get that formula where we say mu E. So a situation where they ask you to find drift velocity and you are having charge, you are having mass and you are having time, you can simply use this one. But if they just give you electron mobility, just use this one. Note it. 3 ways to note velocity. So this kind of question given to us, you can very well see that they mentioned, in this question they mentioned area and they mentioned any charge carrier density. So the one I'm going to be using is simply this particular one, which is VD equals to I over NEA. This is the one I'm using to solve this question. So that's the one I will use to solve the question. Note all these things. Go and watch the video. It's not confusing. Just take your time. And I'm not rushing it. For somebody that will sit somewhere and say it's just that he's not taking it slow. I am slow. It's just that you are missing something, which is going to check the video. I am not fast. I'm very slow. So let's bring out the things we have. Current is given 5 amp. Cross-sectional area A is equals to 2 times 10 raised to the power minus 6 meters squared. Okay. Then charge carrier density. I told you that it's either you call that NE. I told you that there are how many names you call this NE? That is under Q equals to NEAL. I told you that this NE, which is what you have here, that is from VD equals to current over NEA. This thing you are having here, if they don't give it to you in the question to be charge carrier density, you know that you are going to solve for it. And then in that case, I gave you a formula you used to solve for it in our last class. I will not do it again. Check that video. Now, I also said that in a case where they did not give you the charge carrier density, which is NE in this case, that you now need to use number of atoms formula mole to solve for it. We did it exclusively. We took our time drafting all the formulas. Now, or if they tell you that, the question can come, they tell you that you should, they tell you the nucleus, they tell you you are doing whatever, and then they mention the nucleus, or they tell you at the surface. In that case, any now will simply be number of atoms, just number of atoms. Just number of atoms. Let's say they give you a question, and at the end of the day, you now come and hear that the charge is on the surface or is on the nucleus. Any will simply be just number of atoms, because inside a nucleus, you have proton and electron, if you still remember. And if that be the case, on the surface, you have nucleus. So if that be the case, the number of electron or number of proton there is equals to number of the atom. Which means if I have that, let's say it's carbon 6, the any there will just be 6 when the surface or nucleus. But if they did not say nucleus, in that case you use any of the first two I've given you. All these things, for it to make sense, you need to go and check that video, because it's really simple, but you just need to go back to the foundation. So for that reason, my N is not something I'm going to be solving. It's given to me as charge carrier density here. So it's just N equals to 1 times 10 raised to the power 29 per meter cube. So they're not asking me to find the drift velocity. Then remember that E, that is charge. The minimum charge anything can have is the charge of electron or proton, which is the same. That is 1.602, or you say 1.6 times 10 raised to the power 19, Chevy? Thank God. It's 19. So using our formula for drift velocity, I will now have 5 over 1 times 10 raised to the power 29. So that is I over NEA. V equals to 5 over 1 times 10 raised to the power 29 times 1.6 times 10 raised to the power minus 19 times the area given is 5. Chevy? So the drift velocity, please write this D always small so you don't think the D there means something. It's just telling you that the velocity when you're having a source connected. What? Okay, sorry. Okay, it's correct. Thank you. So the velocity that I have here is always a drift velocity. So please put the D there close to it to be small. Or you punch for me. What do you have for everything? Punch. What do you have? It's in tutorial class they impregnate you academically. Yes, it's real life. So you have to take it serious. Any day you miss tutorial, you rush and go and check if video is there. You watch it. You don't miss tutorial, you say you read it inside textbook. Which textbook? Be playing. What's the answer? For everything, Chevy? 1 point, minus? Check, what's the answer? Be sure. Minus 4. Please confirm this answer. Is she correct? Okay. So please, start today. Remember to come with your calculator. Oh, yeah, let's move to the next one. Let's see if we can finish that particular page 8. So that tomorrow is Friday. Do you have lecture tomorrow? Yes. Which lecture? You have physics. Okay. What time? Okay, that means if there is lecture tomorrow, that means we'll have class tomorrow. Yes. Reason being that most of the time when there is no lecture, good number of you like staying in your house. So if there is lecture tomorrow, we'll have class tomorrow. So we'll use it to see if we can cover all those questions. We have a lot of questions under electricity. So that start today, nothing will disturb us with just entering second principle and third principle. What's the time? 3:24. Okay, in the Catholic, Because you need neighbor by 3:30. Okay. That's my arrangement with them is 3:30 on Thursdays. So I think let's just solve the third question. Let's solve the third one and go. Read number 6. Read number 6. Read number 6. Let's solve number 6 and we go. Okay. You have it in your book already, Shebi? But just be reading. Let me be picking the things we need, so I know what to use, the formula we need. That's number 6. The semiconductor, The semiconductor has. This is the symbol for resistivity. Resistivity of 2 ohm meter like this. If I go and be serious, be fast. 0.0. And the charge carrier
0.01.
Hey, is it electron mobility or what?
Charge carrier mobility.
Okay, they don't say density, huh? Okay, meter square per yes. Okay, it's true. So please, you see, I almost forgot. Please don't ever mistake charge carrier mobility with charge carrier density. Oh yeah, go ahead. Number 6.
What is the free velocity of charge carriers when the voltage of 6 volts is applied across the
Come. It has.
What is the free velocity?
Please, who else? Wait, who else has number 6 question? Read, let me hear you.
A semiconductor has a resistivity of 20 meters and a charge carrier mobility of 0.01 meters per voltage second. Carrier retrieved velocity of charge carriers when the voltage
Voltage
of
of.
15 volts
Okay. I wanted to be sure that it's 15 volts. Okay,
is applied across a 3 meters length.
Okay, across a 3 meter what? Oh, I'm good at my good. You come here with problem. Oh yeah, so you see that it's almost like the other one. So please see, the truth is that once you get the concept from that last class and what we did today, it doesn't change. That is why I told you that second semester physics is simpler than first semester because it's not a first semester where you have to pick a lot of formulas, know this one, know this one. Once you master the principle, it's almost the same thing each time. If you know the formula, and it's not something you even need to cram. If something is going to have resistance inside the wire, if the length is too big, that means the resistance will be big as well because it will offer opposition before current will flow. You notice resistance length is directly proportional to resistance. If I know that that wire is very thick, very big, current will easily flow. That means resistance will be smaller. That means it's inversely proportional to area. You notice. And we say that resistance is equal to all the resistance inside that wire. That means we will also improve resistivity here. So check the first class video. So it's not something you cram. Everything is practical. It comes out naturally. So if I know this, to solve this now, the drift velocity will simply be making use of. So you see, once you look at the question, you now know which drift velocity you are supposed to use and solve. Shall you see there's no current there? Shebi? For the fact that there is no current, I will simply use the one that involves electric field, which is the same thing as saying VD equals to electron mobility E. So my business name is to use this voltage to find E. So I'll say you can say, remember, V equals to ER. But when you're talking about a wire, you are not talking about the radius, you are talking about the length. So E will simply be equals to V over L. E will be equals to 15 over the length, which is 3. So E will be equals to what? 5. Shall you see it now? If I get this 5, I'll come and put it for E times this one is already given 0.01 equals to the drift velocity V D equals to punch. What do you have? 0.0. So I'm going to be having meter per second. So please, we'll call it a day here for today. But please, when you go home, take your time.